My name is Jay Sefting, and today I'll be doing my presentation on how sea level rise will affect migration in Southeast Asia. Now, to start off with, I wanted to just give a brief overview of Southeast Asia as a subregion. It's located in the South China Sea, just south of China, just north of Australia, and it is composed of 11 different nations, 10 of which are part of the Association of Southeastern Asian Nations, or the ASEAN. Um, and it is home to over 618 million people, making it the third largest subregion in the world, twice as big as the United States in terms of population, even though it's much smaller in terms of area size. And not only that, it's composed pretty much of all either peninsula, like coastal nations, or just completely island nations. So just looking at this map here, you can see just how vulnerable a lot of these areas are going to be to sea level rise, because they have so much coastline and so much of it is pretty low elevation, which you can see in the light green. And this is backed up by it being one of the most at-risk areas for sea level rise and climate change as a whole. Um, this mainly stems from there being 50 coastal cities with more than 500,000 people, a lot of which are going to be located in these low elevation coastal zones, which just means these are the areas at risk of either flooding or storm surges or sea level rise in general. And this is backed up by the Global Climate Change Index, which ranks four of the Southeastern Asian nations in the top 10 for the most at risk to the effects of long term climate change. Um, and so from there, I wanted to try and figure out first just how much sea level rise would be in Southeastern Asia in general. And to do this, I used three different RCP scenarios to find um, how much the ocean temperature is going to increase and just how much the global temperature is going to increase for both 2050 and 2100. The RCP scenarios I used were the RCP 2.6, 6, and 8.5. I used these ones to try and get a low, a medium, and a high estimates for sea level rise. And to do this, I first looked at sea level rise from thermal expansion of the ocean, which is just when the water heats up, it's going to expand just as a simple proper physical property of water. I also wanted to look at how sea level rise is going to be affected from the melting of the Greenland ice sheet and from the Antarctic ice sheet. So when this was done, I looked at the RCP scenarios for 2.6, which gave a ocean increase of 1.459 degrees in 2050 and 1.466 degrees in 2050. I used the ocean temperature increase to calculate thermal expansion, uh, which will attribute to sea level rise. And then I also did this with the global mean temperature, which I used to calculate the glacial melt. Similarly, I did this for the RCP6, which found in 2015 a 1.588 degrees Celsius increase and a 2.952 degree increase for 2100. And finally, for the RCP 8.5, which is going to give the highest estimate, um, which gave a 2.15 degrees Celsius increase for 2050 and a 4.486 increase for 2100. Now, from there, once I was able to calculate the sea level rise, I wanted to try and look at how the sea level rise is going to displace the residents within Southeast Asia. To do this, I used um, a coastal digital elevation model for three metropolitan areas within Southeast Asia. I did it for Jakarta, Bangkok, and Ho Chi Minh. These are the largest cities in their respective countries. So I wanted to look at that. Um, and then I used that to find out just how many people were going to be displaced. Now to do this, I just got estimates, because the low elevation coastal zone maps, they're not super accurate. They only go from 0 to 3 meters as their elevation for their for their lowest um, range. And so to do this, I made these blocks of this is going to be a 20 square kilometer region. And I blocked these in the low elevation coastal zones to try and come up with the area which was going to be affected. From there, I took the area and I just multiplied it by the population density given of these maps. Now, these are just going to be estimates. So for this one, I did it for Jakarta, Indonesia, the largest city in Indonesia, um, which we'll be able to see in the upcoming slides. Similarly, I did this for Bangkok, Thailand, made a 25 square kilometer block. Found the low elevation coastal zones, which are I just did it for the 0 to 3 meters because, as you'll see none of my calculations predicted anything higher than 0 to 3 meters. So I did that along these regions. I didn't always use just a square block. Sometimes I would cut this up into either quarters or halves or whatnot to try to get a more accurate reading. And then finally, I did it for Ho Chi Minh using these 50 square kilometer blocks. And as you can see, Ho Chi Minh is by far the most at-risk area because it just has so much low elevation coastal zones, primarily under 3 meters. Just a huge amount. And it has a very high population density within that low elevation coastal zone. So for the results, I was able to calculate the sea level rise using the primary data from NASA's satellites based on temperature index, the rise in temperature, and also just from their findings of loss of ice mass from both the Antarctic ice sheet and the Greenland ice sheet. So when this was done, I was able to calculate that there's going to be about a 0.388 meter rise, or 388 millimeters rise in 2050 from the RCP 2.6 scenario, a 388 millimeter rise in 2100 from that same scenario, a 4.26 millimeter rise in the RCP 6 2050, and a 773 millimeter rise in 2100 from RCP 6. And then finally, for the RCP 8.5, there's going to be a 569 millimeter rise in 2050 and a 1.168 meter rise in 2100. And then when I applied those numbers to my low elevation coastal zone maps, I was able to come up with the estimated number of people this would affect for each of the cities. So as you can see, Ho Chi Minh by far the most affected, with up to 2.6 million people being displaced strictly from sea level rise alone. Now I did this by taking my values right here and dividing it by the 3 meters just to try and get at least a rough estimate of how much the sea level rise is going to encroach into that area. And then when this was done, I multiplied it. So right here, you can see those values. I multiplied this percentage by the population within those areas to get my estimated affected population. So in the worst case scenario, Jakarta is going to be the most safe out of the three cities I looked at, with only having 214,000 people affected. But that being said, it's 214,000 people which are going to have to be relocated because of land loss due to sea level rise. From there, Bangkok also. Um, Lower than Ho Chi Minh, but still 670,000 people needing to be relocated. And then, as I said, 2.6 million people for Ho Chi Minh. Um, so those numbers were just strictly from people having to move because the land they lived on was swallowed up by the ocean. Um, and that was just for those three cities. And other studies have went and looked at all the populations within low elevation coastal zones for the different areas uh, in the countries of Southeastern Asia. And it looks even more grim than what I came up with, which you can see here. Um, Cities like Bangladesh and Vietnam have almost half their population living within these low elevation coastal zones, which are going to be affected from either the primary effects of sea level rise of just having the land loss, or from the secondary effects of sea level rise, such as increased storm surges, increased frequency of flooding, an increased water table. All these things are going to affect the inhabitants of Southeastern Asia, and it's going to be a driving force in terms of the migration patterns of the people living there. The people who have their land just completely swallowed up by the ocean are forced to migrate. And then the people who are going to move for more economic reasons, like lack of water, such as the high populations of agricultural societies. They won't have access to these clean drinking waters because you're going to have this infiltration of salt water into the freshwater source due to a rising water table. So people are going to have to move just from those few reasons. And not to mention, people are gonna have to move from an increase in uh, extreme weather events, an increase in flooding, which is just gonna push more and more people out of these low elevation coastal zones in Southeastern Asia. Now, as to what we're gonna do about it, there's not a whole lot of solutions. Some of the simple ones would just be from sea level walls and dike systems trying to block some of the water that's encroaching, try to reroute where it goes. Um, Bigger picture, climate change prevention. If you were to look previously, the RCP 2.6 scenario, a lot of people would still be displaced from sea level rise, but it would be substantially less than those from looking at the RCP 8.5 or the RCP 6. Um, but the main thing that they're gonna have to do is just move. So, for the countries which have lots of area, maybe some higher elevation area inland, these people maybe are going to be able to move inland, try to re-establish their lives. But um, based on current migration patterns, that doesn't seem like the case. It seems that a lot of these people are going to move to outside countries, often from illegal routes. So this is going to have to be an extremely discussed and looked at thing in the upcoming years if we don't do anything about sea level rise, because we're going to have millions upon millions of people re- forcibly removed from their homes due to sea level rise, and they're not going to have anywhere to go unless we do something about it. Um, and in conclusion, it's just this is such an at-risk area, and actions need to be taken if we want to at least give these people a fighting chance. Thank you, Els. This has been a great year, great semester. I hope you guys do well on the rest of your exams. Thank you, Professor Elle, for all your help. Goodbye.